Hello everyone, welcome back again. In this lecture, we are looking at another example of how from a given NFA an equivalent DFA is constructed. So now consider the example here. Construct a DFA equivalent to the NFA given where n is equals to Q0, Q1 is a set of states, 0, 1 is the input alphabet, and delta is the transition function. Q naught is the initial state as well as the final state, where the transition function and the transition diagram are given here. Now, let us construct the DFA here. So, constructing the DFA here, as this DFA is having only NFA is having only two states. So, the subset of states, that is, number of states that a DFA can have is recognized as 2 to the power of 2, that is 4 states, where those states can be epsilon, that is null state, subset of Q naught, subset of Q1 and Q naught Q1, where these are the states that can be existing in the Q prime, that is states of the DFA. Now let us begin the construction by taking the input transitions on the state Q naught, Q1, Q naught and Q1. We'll see whether all the states are reachable or not. Now, beginning with the transitions on the input state Q naught, that is given as delta prime of Q naught, on the input symbol 0, delta prime of Q naught on 0 is Q naught from the NFA, and delta prime of Q naught on 1 is Q1 from the NFA. Now constructing the transition table here, so subset of Q naught on 0 is again Q naught, and on 1 it is Q1 again. Now defining the transitions for the subset Q1 here, so delta prime of Q1 on 0 is Q1 and delta prime of Q1 on 1 is now again Q naught Q1. So that this is a new subset of Q, that is, which is one of the power states of Q prime here. So now updating the transition table here, Q1 on 0 is Q1 and Q1 on 1 is Q naught Q1. Now let us construct the transitions for Q naught Q1 on 0 is delta of Q naught on 0 union delta of Q1 on 0, where Q naught on 0 is Q naught and Q1 on 0 is Q1, that is Q naught Q1 again. And now constructing delta prime of Q naught Q1 on 1 is delta of Q naught on 1 union delta of Q1 on 1, where that is delta of Q naught on 1 is Q1 and Q1 on 1 is Q naught Q1. So that becomes Q naught Q1 Q naught Q1. So eliminating the repeated Q1 here, it becomes Q naught Q1. And finally the transition table here is Q naught on 0 is Q naught and Q naught on 1 is Q1. Q1 on 0 is Q1 and Q1 on 1 is Q naught Q1. This is the new state. And obtaining the transitions for Q naught Q1 on 0 is again the same state, that is Q naught Q1 itself on the input symbols 1, 0 and 1. Now, as there are no new states in the DFA, so we will update the transition table for the DFA as Q naught on 0, Q naught on 1, Q1 on 0, Q1 on 1, Q naught Q1 on 0 and 1. And the DFA is constructed like beginning with the initial state Q naught here. So Q naught on 0 is Q naught itself and Q naught on 1 is Q1, that is a new subset of state. And Q1 on 1, that is now defining the transitions for Q1 here. Q1 on 0 is Q1 itself, where Q1 on 1 moves to a new state, that is subset of states, which is Q naught Q1. As Q naught is the initial state and the final state here, so the subset of states containing Q naught is marked as the final state. Now defining the transitions for Q naught on 0 and 1, where both of them refers to the same state itself, which can be given like Q naught on 0, 1 is again Q naught Q1. And so if we observe the final state here, so the final state of the NFA is Q naught, and here the subset of states containing the Q naught will be marked as final states of the DFA. So this is one of the final states and Q naught, this is also one of the final state, where this is what the DFA, equivalent DFA that is obtained for the given NFA. Thank you.